Meanwhile, in the Smash Tower.
I don't know what was up with that. Anyway, we are back with more space weather, and looking at the sun on 193 angstroms here. We are looking at a coronal hole north of the equator here, swinging into the Earth-facing region, and we've had a bit of a science overload in the past day. And yes, indeed, we did miss the coronal mass ejection that occurred, but it's just all the more reason why it's super obvious that coronal mass ejections do not require any sort of X-ray flares to be initiated. And we're going to show you a little analysis of that in a minute. I did monitor Earth-facing coronal mass ejections, and again, it's been a science overload. So here's a close-up of the 193 angstroms view. Coronal holes facing the Earth, diffuse ones, and another diffuse one north of the equator there. Area of magnetic complexity right here. Let's look at the magnetogram. And there you see that area of magnetic complexity. Another area of a little bit of activity rising there. Nothing like a sunspot any place on the sun right now. This area that magnetized yesterday did not gain in complexity. And let's give our viewers an analysis of what it is I look at every day, as there were no coronal mass ejections facing the Earth, at least that we could see. Let's take a little aside here and look at the visible. And again, there you see the visible. There are no sunspots on the solar disk. No X-ray flares or anything like that. Now let's take a look at the LASCO images that show great images of this massive coronal mass ejection that just came from a filament eruption in the northwest portion of the sun, and it primarily blasted off to the west. Here's the image. Make sure you can see the date stamps there. I'll let that play through. And you see that coronal mass ejection happening yesterday, basically right as we made the video. So not sure whether we would have been able to see that or not, but in any case, there you have it. That's the LASCO C2 one. And we do see another coronal mass ejection at the same time coming out of the eastern limb, more toward stereo A, but we don't really see any kind of a halo coming toward stereo A, and we'll get to it in a minute. Let's go to the C3 here. After that plays through one more time. And there's the C3, a more zoomed out image, the SOHO coronagraph. And we'll let that play through a couple times for your viewing pleasure. A prime example of coronal mass ejections when there are no sunspots, no X-ray flares detectable at least from earthly locations. Again, there could have been an X-ray flare, but we didn't detect any. And you can see that coronal mass ejection out of the eastern limb is actually still progressing now. But I'll show you what I look at daily in order to look for Earth-facing coronal mass ejections. Here's what we use for that. And this is the view from stereo A, and there is actually, you do actually see a halo, indicating that that second coronal mass ejection is headed towards stereo A. So let's hope it doesn't take too much damage. Probably won't take any, as it's probably been through that countless times before. But if you look over here in the right, you don't really see any plasma being slingshotted toward Earth. You see it going off in the opposite direction, and most of that coronal mass ejection must have gone off to the west. And perhaps part of that halo is that coronal mass ejection going to the west, but in any case, nothing Earth-facing. 10.7 centimeter radial flux, still at 71. And let's look at the magnetic environment here with the opacity fade in with 171 angstroms. There's that view. And here's the magnetic environment. We'll fade that out slowly. And there you see that small area of magnetic complexity north of the equator there. which is, by the way, a cycle 25 plage. Just to go back to the colorized magnetogram real quick. Actually, I stand corrected by myself. That is a cycle 24 plage, as the leading polarity there is South Pole. So, kind of odd, actually, as it's very far off the equator. Got the same polarity as this one, which is a little closer to the equator. Yeah. All right, let's move on here, as there's lots more stuff to talk about, and we got to get through the video and get it encoded and all that stuff. All right. So there's the view from HelioViewer. Fade that out again. 171 angstroms shows great magnetic looping. And we do see some activity picking up at the same time as a 10.7 centimeter radial flux. Regarding the electron flux, it's pretty cratered here, folks. And I don't know why it's zooming. There you go. There's the electron flux, quite cratered there. These measurements by the GOES 16 and 14 are near the F2 ionosphere layer. And for you new viewers, the N's and M's refer to midnight and noon time, local time for the satellites. Relativistic electrons are in a low to moderate range. GPSs should be working all too well. Although there's a bit of a...
It's really laggy.
Although there's a bit of a failure going on regarding the stream quality, apparently. So how laggy is it? Is it too laggy to continue?
You can't even see the webcam. Like, when you move in the webcam, it doesn't match at all.
Wonderful. But the audio is perfect.
Yeah. It's just the webcam is really laggy.
Anyway, there are the GOES magnetometers, and we apologize for any quality problems regarding the webcam. I believe we'll have to mess with the resolution settings, as we had to reinstall software entirely. Anyway, there's the GOES magnetometer, and we are expecting a heliospheric current sheet boundary crossing coming up very soon in the next 24 hours. So the magnetometer is going to go haywire for a moment. Once again, especially with such low electron flux levels. And we have seen some oddities in the solar wind over the past 24 hours also. And when I talk about science overload, no kidding. Anyway, this data 1 hour and 58 minutes old. You can see the Earth's field line is approaching, if not already in the crossing mode. So expect the GOES magnetometer to freak out today for a bit as we enter the North Pole associated portion of the heliospheric current sheet shown here in green. If you're not familiar with the term heliospheric current sheet, look it up. I assume you have access to the internet, or you probably wouldn't be seeing this video, right? Anyway, real-time solar wind showing phi angle at whatever, 314 degrees. And we see a steady solar wind density over the past 12 hours and a very highly fluctuating solar wind speed. So current solar wind density, when this video is made, at 5:29 a.m. on 12/11/2019. Solar wind at 422 kilometers per second right now. And again, 3.87 protons per cubic centimeter density. There's the data from ACE, the other spacecraft primarily used to measure this, at least by Americans. And here are the geospace magnetosphere movies, looking at the magnetohydrodynamic pressure, which is fairly steady here. And you can see the kind of pulsations that you would expect from that solar wind. And next we'll look at the geospace ground magnetic perturbations. I apologize if the video and the webcam is not synced. Anyway, there's 4 hours of data. And it looks like there could be 2 south poles forming here. Not sure. North Pole main perturbations appear to be coming from Canada, not Siberia. And we do see a signal coming from Siberia, just not as much of a signal, indicating more current appears to be flowing through the Canadian pole than the Siberian one. Here's the ionosphere, and it's looking a little on the anomalous side here. South Pacific still showing some oddities. And mainly charge up oddities. Right around the equator, southeast of Hawaii. Anyway, here's the latest image. And we got to keep moving on. There are so many articles to cover. You see a massive charge disparity right there, going from 4 all the way to 1 megahertz. As well as in this region, approaching the South Atlantic anomaly and so on. And let's keep moving here. KP is back to 0. And we're going to skip cosmic rays today, but we've got links to the cosmic ray stations in the description. Science overload! It's a science overload, folks. We don't see any earthquakes of a 6+ magnitude, but we see issues happening at New Zealand with the White Island volcano, that is. And let's just scroll up the list here. We see some 5 magnitude quakes there around Japan. None at an extreme depth. But there's a 4.5 at extreme depth, 435 kilometers. Again, a 4.5 magnitude. Fairly large quake there for Greece. Hopefully that didn't cause too much damage at a 5.4 magnitude. As well as a deep quake nearby at a 4.8 magnitude and 155 kilometers depth. Here's a very deep quake at Fiji also, 498 kilometers at a 4.4 magnitude. And let's keep this thing moving to the windy.com pressure maps. And we'll let that advance. As high pressure dominates most of the eastern portion of the United States, we've gotten hit by some snow here in Pennsylvania. I do believe I shall be cleaning off a car later this morning. Anyway, let's continue on here, as I'm not sure what the quality is going to look like. Let's hope it looks good enough. And I have one question to ask all of our viewers. Where does the Earth's electron availability come from, and is it related to all that hydrogen in the deepest boreholes? I say it is. Some people probably disagree, and cheers. Cheers to those who agree, disagree, or have an alternate theory. White Island volcano is located right there, north of the North Island of New Zealand in the Bay of Plenty. Why do we care? Well, because it's been erupting. And people have been dying there, folks. Apparently, GeoNet's warning that more eruptions likely in the next 24 hours. Now, there are a bunch of people missing there. I think still 7 people missing there. Expected to be quite dead. And since the alert levels have been raised, people weren't even supposed to be there, and there are criminal investigations opened as a result. If you want to follow the... what happened there? If you want to follow the White volcano and other New Zealand volcanoes, check out geonet.nz. It'll refer you to geonet.org.nz. And this is probably the most up-to-date information if you want to monitor that. We've linked that in the description also. Let's talk about microdepressions and pockmarks off the seafloor of California, off the coast of California on the seafloor. And one interesting thing about these is that every one of these holes has plumes, debris fields that are pointing down the same line. So I find that very interesting, as that's, well, let's just say there are going to be theories abounding about this. And they've been looking at the area because they're thinking of putting a wind farm there. And they're a little concerned, well, if we put a wind farm there, why did these holes form? Are they stable? And what geologic process formed them. Let's don't go there. I know our viewers have ideas. Let's do the volcano rundown. And white volcanoes on the list now. First, let's start at Mount Aso. Probably erupting. Cloud unknown because satellite imagery is not visible. Sakurajima, flight level 9,000. Sanjiangapi, flight level 8,000. Tokono, flight level 6,000. White Island. Sustained increase in seismic tremors beginning just this morning, just a few hours ago, folks, indicating that the system is still under pressure and we're seeing energetic steaming and mud jetting. So I wouldn't be hanging around the White Island volcano. Fortunately, it's pretty far off the coast, and as long as you don't do something stupid like land a boat on the island or hang out within a mile of it or so. Anyway, Sangay producing a 22,000-foot ash plume as it explodes. Ravenador also exploding. Flight level 20,000 there. Intermittent puffs at Sabancaya and intermittent emissions at Nevados de Chilean. Please don't pull Volta Caldera. Here's where planets are in the solar system. There's where things will be in 1 week. And please stay tuned as we try to keep the videos as dense as the brains of our viewers. By the way, having a dense brain is a good thing. Being dense is a bad thing. There's where stuff is above my head. If you want to make yourself a sky map, check out in-the-sky.org. Are you familiar with our mission on the smAsho channel /smashomash.org and all of that stuff? It's the main one, and number one is to assist study and report on the ongoing formation of a unified theory of physics. And indeed, welcome to the Neo-Renaissance, folks, as science is being rejuvenated by actual observations of the real natural world. And cartoons are being debunked. Check us out on BitChute, Gab, Minds.com, all over the place. Also on Instagram, where we are a little bit critical of certain big tech organizations, not mentioning any names. Junkware. Check out lightningmaps.org the next time you hear thunder, perhaps. Check out all the lightning in the Mediterranean. Plenty of lightning out there. And let's do value-added services. Looking at the U.S. Doppler radar and seeing an atmospheric river. And we're looking at yesterday's animation here. I don't know why. I didn't think it looked right, folks. As we just got snowed on here in eastern Pennsylvania. I thought it looked awfully bright when I looked out the window, and that's because there is snow out there. Anyway, there's today's, I apologize, there's today's U.S. Doppler radar map. And the snow is just on its way out. Although I should see significant snow as I see bands where there was probably an inch an hour falling. Please leave a comment with your local snow totals. Here's the U.S. water vapor map. And this time it is today and just right now, basically. The last few hours. And we're going to see some frigidly cold air moving in as the jet stream injects some more Canadian air, which is currently hitting northeastern Minnesota and moving into Wisconsin over the Great Lakes. If you're on the Great Lakes, get ready to freeze up. It's going to be chilly. Not Chile, chilly. Here's the jet streams in the eastern world. Looking fairly organized, although doubled up in the north. And here is the western world. Extremely meridional in nature. We see a 180-degree turn in the Atlantic Ocean. Actually, more like two 180-degree turns in the Atlantic Ocean. One right there and one right there. Check it out. By the way, please support the channel via Patreon, the real source of funding for the entire operation here. Patreon.com/smAshomash. Or if you don't like Patreon, because they take a cut, it's a very small cut, by the way, you can also donate via PayPal. By the way, the top tier on Patreon is $9.99. Also, please press like and subscribe and get involved and leave comments and share on your social media and Share with your friends. Share with your foes. And by the way, if you're not familiar with our live streaming on Twitch, we're live streaming on Twitch literally right now. So here's what's going on with that. And yeah, again, sorry about the webcam not being synced up, but hey, what can you do? Thanks, smAsho team, for tuning in. Again, please like and subscribe wherever you're viewing it, whether it's on BitChute, Minds, YouTube, Facebook, whatever. Bonus features abound. The magnetic field of the Milky Way galaxy has been plotted out. And I would note that this portion around the Cygnus arm all appears to be a magnetic field away, pulling away, while on the other side, toward the Vela pulsar, appears to be pulling toward. And I would also note the way that these fields kind of be right next to each other. You notice the way that they're a bit organized here. You see the way they line up side by side, and the way you got these purple zones in here toward the galactic core. Probably not that much of a surprise if you understand magnetohydrodynamics, but it's a great article from Universe Today. Perhaps have a reading of that. The LOFAR system, which is a series of radio telescopes spanning a great distance, took these measurements, and it took quite a while. So nice job, LOFAR crew. Again, links to the article are in the description. Eventually, not on Twitch while we're doing it live. We do that while we encode the videos and upload them to other places such as BitChute. That's bitchute.com/smAshomash. And YouTube. Happy birthday to the XMM Newton, celebrating today, actually yesterday, 20 years in space. It's the largest object ever built by the ESA, and it's an X-ray observatory. So read about that if you like. Also, cheers, holla, etc. You can't report the science news instantaneously, folks, because it takes a second to sink in. So I apologize for the science overload that's been happening. But anyway, also check out the XMM Newton's website, which we've also linked below the video eventually. The XMM Newton Science Operations Center. So check that out. They just put up an article yesterday about their anniversary, and they're fairly active there. The last article was from September 13th, talking about mysteriously in-sync pulsars, which, by the way, maybe we'll highlight that tomorrow. And stay tuned for another bonus feature, folks. We're going to show you the 48-hour video of the local yellow dwarf in 304 angstroms. So thanks again, everybody, for tuning in. We're going to let this play through a few times for your viewing pleasure. Date stamps visible at the bottom. And I'm just looking to see that filament eruption. The filament comes from up in this area, and it kind of comes down this direction. Kind of difficult to see in the 304 angstroms view. We did look at it yesterday on the space weather video, and we didn't even realize the CME was there until a little bit later in the day. But again, prime example of how a massive coronal mass ejection can happen with 0 X-ray flares and 0 sunspots. So thanks again for tuning in, everybody. We are out.